My name is Yuling Chai,
My name is Simon Tang.
and what are we doing today?
We're comparing distributions to the normal model.
Okay. So, normal models and three things about them.
First, we have the shape of distribution
Mean, standard deviation, and spread.
and the empirical rules of 68%, 95%, and 99.7%.
So, shape of the distribution. A shape of the normal graph, a normal distribution, should normally be symmetric, bell-shaped, and curved around the mean.
This symmetry implies that most data points cluster around the mean with fewer data points further away from the mean.
Mean, standard deviation, and spread. The mean represents the center of the distribution.
The standard deviation measures how spread out the data is.
A smaller standard deviation means data is tightly clustered around the mean, while a larger standard deviation means that there is more variability.
Empirical rule 68, 95, 99.7. Within a normal distribution, about 68% of data falls within one standard deviation of the mean.
95% falls within two standard deviations of the mean.
99.7% falls within three standard deviations from the mean.
The empirical rule helps interpret how much data lies near the mean and predict the likelihood of data points falling within certain ranges.
Here's a graph of what it looks like.
So the first standard deviation would be 68%, and each side of the mean of the first standard deviation would be 34 and 34,
And each side would be 13.5 and 13.5 for the second standard deviation.
adding up to 95%.
And each side for the third standard deviation will be 2.35% on both sides and adding up to 99.7%.
Here's our normal distribution graph of the um, students' years of age.
And here's the um normal distribution with the exact sample data, so they're together. And also with 68% range, 95% range, and 99.7% range.
So, according to the normal distribution graph and the empirical rule, 68% of the data should be within one standard deviation of the mean.
The actual data distribution shows that 67%, or 22 out of 33 of the values, fall within one standard deviation of the mean.
And according to the empirical rule, 95% of the data values should fall within two standard deviations of the mean.
And the actual data distribution shows that 97%, or 32 out of 33, of the age values fall within two standard deviations of the mean.
Finally, according to the empirical rule, 99.7% of the data values should fall within three standard deviations of the mean.
And what this means is that the actual data distribution shows that 100% of the age values fall within three standard deviations of the mean.
So, in conclusion, I would say that the normal distribution representing the age value of students in my class wouldn't be a good fit for the data values. This is because it breaks the empirical rule of 68, 95, and 99.7.
And 67% of the age values fell within one standard deviation of the mean. 97% of the age values fell within two standard deviations of the mean. And 100% of the age values fell within three standard deviations of the mean. So basically, um, these age values do not match the empirical rule of 68 and 95 and 99.7.
So the normal distribution will not be a good representation of these data values. Thank you.
Thank you.